All right, let's talk about some more cell phone DC electronics. So this time we're going to talk part 5, opens and shorts. Not the kind that you wear on the beach. This is a short in an electronic circuit. So the circuit as you see it right now would be considered an open in the diagram. The diagram has a voltage source and it has a negative and positive pole, as well as the little ground symbol at the bottom. Now, the reason that this is open is because the circuit is disconnected. And the reason that this is important is because if you have a cell phone that is not consuming any voltage, basically is not consuming any current by taking that voltage, then essentially you have an open somewhere. And an open means that if you were to think of it as a bridge, there's no traffic that can flow through the street if the bridge is up. A bridge is essentially a circuit, part of a circuit for the roads. So if a bridge is up, that means that nothing can travel over that road. And if the bridge is down, then that traffic can travel again across that road. So an open circuit is when the bridge is up in a circuit. Okay, so here is a closed circuit. Now, technically, if you were to do this to a battery, this would be a short because you don't have a resistance besides the line, which is very, very, very low resistance. Basically none at all. That battery is essentially just going to, well, the way that it works is that the amount of current traveling through that line would not be rated for the amount of current. The battery would be so hungry it'd pull all the electrons that it could until it reached a balance as quickly as it could. It would heat the line up and essentially the line would blow or the line would break. Um, the amount of heat and friction from all of the electrons traveling through that line would make that line disintegrate at some point in the line. So, and the reason this would happen is because the line can only hold so many electrons at a time. The potential between the two poles is so great that it doesn't care. It'll just keep pulling until that line basically implodes in on itself. And so this would be considered a short. And this is a short to ground. Hungrily consuming all of the energy. Electrons travel through the point of least resistance. So if you have a short to ground somewhere, all of those electrons are essentially traveling to your short, not to their destination. And that's why you can feel a lot of heat, because it's trying to pull as much as it can from that ground plane. Another thing is that a lot of times components will short internally. So you'll have this same type of circuit where there's no resistance whatsoever, the current is unregulated, it's pandemonium. Going back to the sports analogy again, it's like somebody just yanked out all the gates out of that sports complex. And so everybody's just running free through the place where the gates went. There's no order to it. So that is the difference between an open and a short. An open, you can't pass any electrons through an open because there's no connection whatsoever. And a short is that the connection is routed to, well, essentially a short is a closed circuit, but the circuit is closed in a way that you wouldn't want it to be. So in a sense, what you're seeing in this diagram as well is a closed circuit. There is the ability for the poles to transfer electrons between each other, but you don't want those electrons to travel to your ground plane if you want them to complete a task before they go back to the ground plane.